In this video, we're going to solve log equations. There's two types of log equations we're going to look at. The first type, we have a log equal to a log. They both have the same base. So it looks something like this. Log base b of expression 1 is equal to log base b of expression 2. The only way for this to logically make sense and logically work out for the equal sign to mean what it actually means is for expression 1 to equal expression 2. So in our first example, we got log base 7 and log base 7 on both sides. So the only way for this to be equal is for the 4p minus 2 and the negative 5p plus 5 to actually be equal. We're going to solve that equation. We're going to add 5p to both sides. The 5p's cancel. At the same time, we can move the 2 to the other side by adding 2 to both sides. We get 9p is equal to 7, and then we can divide both sides by 9. So we get p equals 7 over 9. The number inside the log must be positive. So like this number right here must be a positive number. It cannot be 0 or negative. Why? So if you think about this, like log base 3 of some number, this number right here has to always be positive. And why is that? Remember, the log is always equal to the exponent. So 3 to some exponent has to equal a positive number. Well, why does that make sense? Well, your first instinct would be like, oh, that number could be negative. Let's try a negative exponent. So something like 3 to the negative 2. Well, 3 to the negative 2 is just 1 over 3 squared using properties of exponents. And 3 squared is 9. Guess what? That number's positive. So we might try 3 to a positive exponent. Well, that's just 9. Guess what? That number's positive. The only other exponent we might try is 0, and anything raised to the 0 power is 1, still a positive number. So this number inside the parentheses has to always be positive. So let's look at our second example. X squared minus 30 has to equal x. This is a quadratic expression, so we subtract x from both sides to get our equation equal to 0. So x squared minus x minus 30 equals 0. What can we multiply to get negative 30? That adds to give us negative 1. That's negative 6 and positive 5. So our two solutions would be x equals 6 and x equals negative 5. However, because the number inside the parentheses cannot be negative, we need to check these answers every single time we solve a log equation and make sure that the numbers inside these parentheses are positive. So if we plug in 6, we get 6 squared minus 30, which is equal to 6. And on this side, we get 6. Those are both positive. So 6 checks out as an answer. If we plug in negative 5, though, we get negative 5 squared minus 30. That's negative 5. That's not good because we can't take log of a negative number. And on this side, we would also get negative 5. Yes, the left and right-hand sides are equal, but we can't have log of a negative number. So x equals negative 5 is actually not a solution. So the only solution would be x equals 6. Our second type is going to be log base b of an expression equal to a number. We want to isolate the log, rewrite it as an exponential, and solve the resulting equation. So in our example, we're going to get this log piece by itself. So we've got to move the negative 10 and the 4. So we're going to add 10 to both sides. So we get 4 log base 3 of 2n plus 3 is equal to 0. We can divide both sides by 4. So we get log base 3 of 2n plus 3 is equal to 0. Now we're going to rewrite this as an exponential because we can't solve for n because n's inside the log. But if we write this as an exponential, this is the base. This number over here is the exponent. So 3 to the 0 is equal to 2n plus 3. 3 to the 0 is 1, so 1 equals 2n plus 3. We can subtract 3 from both sides. 1 minus 3 is 2. So 2 is equal to, negative 2 rather, is equal to 2n. And then we can divide both sides by 2, and we get negative 1 is equal to n. Well, if we plug negative 1 back up here in the original equation, 2n plus 3, well, 2 times negative 1 plus 3, that's negative 2 plus 3, that's 1. That's a positive number. So n equals 1, negative 1, checks out as our solution.